For this problem, we will be going over problem 2. It asks, a horizontal pipe contains a dilute solution of sulfuric acid H2SO4. Under the conditions, the sulfuric acid dissociates in negative sulfate ions and positive hydrogen ions. There are 4 times 10 to the 25th sulfate ions per meters cubed, with a charge of negative 2e. And an electric field is applied to the right along the pipe, and the hydrogen ions acquire a drift speed of 9 times 10 to the negative 5 meters per second, while the sulfate ions acquire a drift speed of 2 times 10 to the negative 5 meters per second. The pipe has a cross-sectional area of 2.4 times 10 to the negative 4 meters squared, and the question is asking what is the magnitude and directions of the conventional current. So we know that current in total is going to be equal to the current of the hydrogen plus the current of the iSO4. So first we want to find the current of the hydrogen. So we know that the relationship of little I of H is equal to NaV, and that's and for this you're just going to plug in the numbers that you already have, and that's going to get you a value of I to the H equals 1.7 times 10 to the negative 8H over S, which relating little I back to big I, you just times little I by the charge E, which will get you a total of 0.277 amps. So now we have the little I for H, and we now need to find the little I, or we have the big I for H. Now we want to find the big I for SO4. So we're going to use the same equation, except instead of finding little I, we're just going to go straight to finding big I because we know the relationship, which will give you a value of 0.0615 amps. So to finish this problem, we go back to the original equation we had of the current is equal to the current of H plus the current of SO4. So we just add those two numbers and we get a value of 0.338A, and that value and the current is going to the right.